Okay, welcome everyone. My name is Andrea Aime, and this presentation is serving Earth observation data with GeoServer, COGS, STAC, OpenSearch, and more. So first, quick description about my company, GeoSolutions. We have offices in Italy and also in the United States. It's an engineering-heavy company. There are 25 plus engineers plus 5 people that desperately try to manage us. Somehow they manage to. We serve and contribute to a number of open source projects, including GeoServer, and we provide services around it like enterprise support, custom development, bug fixing, training, assessment, and so on and so on. Whatever you think you might need around GeoServer, we can provide it. The company is very much open-based, as in open source and open services and open standards. And yeah, let's have a look at what today's topic. So the scenario is you got a ton of raster data coming from satellites or whatever other sensor you might have, drones, aerial mounted reconnaissance, whatever. And the first thing that you might need to do is to locate interesting data out of that massive pile, which is what I just said. The classic way to do so nowadays is to use STAC. Spatio-temporal as a catalog, it's an OGC API that is a derivative or compatible with OGC API features. It organizes stuff in collections, which are typically satellite or sensor-based, so they are uniform in nature. Each collection contains one or more items or products, which are typically satellite takes, satellite scenes, strips, whatever. And then each product relates to a number of assets, which are your files, the raster files, the metadata files, the cloud and snow masks, whatever you might have in your product. So the idea is that you decide what collection you want to search. You search over it using time, space, attributes like, I don't know, give me all the scenes from Sentinel-2 between these dates with a cloud cover of less than 10% and an off nadir less than that and this and that and so on, and you get our results, which then you can explore and eventually download through the assets. The STAC API has an HTML interface which is fully customizable, so using free marker templates in GeoServer. And this is a customization that the German Space Agency did. They are implementing their own STAC API using GeoServer. And as you can see, they customized a little bit the logos and the layout of the page. But when we go to the list of collections, these are collections from their service. And by the way, I think, do I have? No, I don't have a, sorry. I thought I had a link in here, but it's not there. They customize the collection space by adding thumbnails and a bunch of other keywords and attributes and so on, which are not part of the standard HTML layout in GeoServer. When it comes to the single product, they also added, again, a thumbnail and a bunch of extra links. And then you go to the, sorry, that was a collection. This is the items, and this is the single item. In the single item, they even added a couple of dynamic previews of the single item that's browsable, so it's an interactive open layers display of their data. And again, this is not part of the classic GeoServer output. They customize it deeply to get exactly what they want. All of this is based on a database which was actually built for an older specification, which was OpenSearch for Earth observation, which is a 2017 specification, and the GeoServer still supports it, so it's you also have the opportunity, if you have any need to use this older version of the service, to do searches using this OpenSearch for you. There is a REST API to manage the contents of the index database for the catalog, so you can automate fully the management of the index contents. And you can even create image mosaics on the fly based on a collection or a part of a collection, and then publish it as a layer in GeoServer. So it doubles down both as a search engine and as a tool to build on the fly image mosaics out of your index data, which is kind of handy, because then you have a WMS or OGC API maps or WMTS based on those image mosaics. As you provide searches, you provide also ability to view and browse. So, speaking of which, how do you access raster data? Well, STAC has assets, and each item has a number of assets, and it's pointing to the raw files, so you can just go and download them if that's what you need and want, because you need to do some processing offline and stuff like that. Then it's all fine and good. Otherwise, GeoServer can put together WMS and WCS on top of those files instead and make them accessible through those services. Where can you put those files? Well, local file system, HTTP server, blob stores, they're all good. It's either using classic TIFF or a cloud-optimized GeoTIFF plugin, which we have variation of depending on the type of cloud you choose. So Azure Blob Storage, Google Blob Storage, S3 for AWS, and so on. The plugin takes advantage of the optimized nature of the cloud-optimized GeoTIFF layout and basically reduces the number of reads we do against the blob storage to optimize performance. Okay, so we have our catalog. We can access all the files directly or through the COG interface. What do we do with it? We typically mosaic them. So, mosaicing terminology, in GeoServer, the image mosaic plugin is basically an index, which is a vector database with all the footprints of all the images and their main attributes, which is typically their time, cloud cover, snow cover, whatever, anything that's filterable that you will want to filter on to compose the final image. You can decide which images goes into the final mosaic by using the alphanumeric attributes and just cast down to the exact composition you want to get to. The mosaic allows you to have a complete freedom in terms of the granules. The granules are the single files in the mosaic. They can overlap as they please. They don't have to be nicely aligned. They can be in different file formats. They can have, within reason, different color models. So we can have a mix of RGB, gray, paletted, and so on. And they can be in different coordinate reference systems, which is important because nowadays, if you go and download Landsat or Sentinel, they are probably delivered each one in their own optimal UTM zone. The mosaic index, as I said, it's a granule lookup system. It's a table of granules with their footprint location and all the extra attributes. You can put this index pretty much wherever you want. It can be a shapefile, it can be a Postgres database, Oracle, SQL Server. It can be another STAC API. Maybe you are trying to image mosaic data from a remote STAC API. You can do that. So you can use the remote STAC API as an index for the image mosaic. And if you're not happy with it, the image mosaic allows for plugins to be written to talk to whatever existing legacy catalog you might have in-house. Some of the columns have a particular importance in the index. We call them dimensions. They are typically time and elevation, but they could be wavelength or whatever you decide them to be. So time and elevation are recognized by WMS and WCS as well-known dimensions, so they have a special treatment in the protocol. And then typically in WMS, you also have custom dimensions that you declare and say, yeah, I have a dimension which is a wavelength. The unit of measure is this one, its description is that one, and the possible values, here is a list. And then you can use them to filter and do stuff in services. You can use the internal STAC as an index for an image mosaic, as I was hinting about before. So through that REST API, you can decide to create an image mosaic out of a collection or a set of products in a collection that match a certain condition. And as I said, you can also use an external STAC API through the STAC store. The STAC store is a GeoServer data store that can talk to an external REST STAC API and then deliver the footprints as vectors. Then you can put on a map, but also act as the index for an image mosaic, which then will fetch the rasters, hopefully through COG from the remote storage. I have a bunch of documentation links that you can follow in your own time after this presentation if you go and grab the slides. And I'll have those for every section in this presentation so you can go and get into more detail later. Image mosaic, the fun stuff. Okay, we know the basics. What can we do once we have an image mosaic index? Well, filtering and sorting comes to mind because it's a table, no? So whatever you can do on a database table, you can do on an image mosaic index. So image mosaic index can be filtering using OGC API, OGC filter, SQL, SQL2, whatever, and you can say something like, okay, I want the sensor to be SAR and the satellite to be DAT, and maybe the cloud cover and the snow cover to satisfy certain conditions. This reduces the set of images that will be mosaic together. And then, very important, you can also sort them so that you have more recent on top or less cloudy on top. And so make sure that you have the best imagery for the task at hand on top, and then you fill in the gaps with older images, with more cloudy images, whatever. We have a notion of coverage views, which are useful to put together data that is somehow split into separate files back into one. Typical use case, Sentinel-2 or probably also Landsat 8, they are typically multi-resolution sensors, and so the data is not stored at a single 13-band file, but we have one file per band, and some files are at 10 meters, other at 20, other at 60, and so on, depending on the nature of the sensor used to collect the data. But when you want to see them, you typically want to put the bands back together to do raster algebra, to do false color display, and so on. So coverage views allow you to say, okay, I got this bunch of separate raster layers, and I want to put them together in a virtual multi-band raster that I can then use for my computation and display. Coverage views do exactly that. This is one example taking data from a NetCDF that has two separate rasters, which are the UNV component of the wind vectors. But to display wind barbs, you need to put them back together to do calculation of magnitude and orientation. And so that's exactly what coverage views do. And then we do the math in the SLD. So we have native multi-coverage support. This is very important for, as I said before, Sentinel-2, Landsat 8, and all these multi-band, multi-resolution sensors. We added recently is like a year or two ago, proper support for hyperspectral imagery. What is hyperspectral? Well, it's multi-band on steroids, hundreds, thousands of bands. Typically, this time, all sharing the same resolution, and they are stored in a very specific way so that you can efficiently extract one slice out of the large deck of bands. And GeoServer had some troubles dealing with them, but we fixed it, and now it can efficiently access and render hyperspectral imagery without particular problems. And a bunch of documentation links for you to explore later. The services, visualize. Okay, so we collected all the images, we put it back in a mosaic that can then filter them and sort them and so on. Okay, what can we do with it then? Well, look at it. So WMS can display the image mosaics, of course. And here we come back with the notion of dimensions. WMS has first-class support for time and elevation as dimensions, and you can publish and advertise that the dimension is there. You can say which values are valid, which time slices you have. That goes in the capabilities document, and that helps the clients to build the right query and say, oh, okay, I would like this image mosaic for this particular time. And then you have it on screen. Or maybe for this particular time range, which catches a number of images, and then you have a composite. Filtering can be done, in this case, the simple way, standard way, with time and elevation and a couple of custom dimensions. But if you want to go alphanumeric, you can use SQL filter and then use whatever attribute you have in the image mosaic to do your filtering and to do your sorting. And so this is a couple of examples of two compositions, one sorted by cloud cover, the other one sorted by time. So the one tries to show the most recent data, even if it has clouds. The other one tries to provide a composite which has the least amount of clouds instead. Rendering transformations are another interesting thing in the WMS capabilities of GeoServer. This is not part of the standards, it's something specific to GeoServer. It's the idea that from the style you can drive some on-the-fly computation, like contour lines extraction, like wind barbs extraction, like raster algebra on the fly. So this is, for example, one contour line extraction that we do on the fly. It's very fast because we extract the contours on the fly at the resolution of display, not against the original raster data. So we are always dealing with a small amount of rasters when doing this on the fly. Two more examples, wind barbs, current map, and one more example using GFOL, which is our raster algebra language that computes on the fly from a multi-band map, an NDVI index. So it's basically doing simple math on top of the bands and computing an index which is then displayed through a color palette. And this is done all on the fly. We don't store the NDVI anywhere. And a bunch of documentation links for you. Okay, you have seen the data, you like it, you might want to download it. How do you do it? First option is to use WCS, Web Coverage Service. Web Coverage Service is OGC service to download raw raster data. So it enumerates all the rasters that you have, all the image mosaics, can describe them, and then you can say, oh, okay, now given this particular coverage that does this four-dimensional bounding box, space and time, and that has a set of custom dimensions and so on, I wanted to extract exactly the rasters that match this SQL filter, this sorting condition if I'm mosaicing granules, and basically I can get the raw data that was backing the visualization that I saw before. And this is all great and nice, and it's all based on a well-known standard, but it has one drawback. WCS is synchronous. So you make an HTTP request and you wait for the response to come back. If you wait too much, something will say, yeah, this request has been sitting there too long. I'm going to cut the network. you don't get the response anymore. So for very large extractions, we have to go to WPS, Web Processing Service. Processing is designed for analytics, but literally can do anything. And why do we go to WPS? Because it's the one and only service in OGC services that can do asynchronous requests, where you post your request and you get back a polling link, and then you can poll over it and say, okay, are you done? Are you done? And he says, yeah, I'm at 50%, I'm at 70%. Oh, look, I'm done. Here is the link to download the results. And this is something that we can use for very large downloads, among the other things. And so we designed specific processes for large downloads, large raw downloads, and you identify a very large area and say, oh, I really like to download everything in this area at native resolution. And maybe half an hour later, you go and download a 100 gigabytes raster file that has been prepared for you in the meantime. If you are interested in large render maps, like you would like to have the results that you have through WMS with the NDVI and so on, and you would like to just download the result, but at high resolution, again, you can do it. And we have a large rendered map download facility that allows you to basically mimic a WMS request, but at a very large dimension. If you are still not happy, you can identify a sequence of times that are of interest to you and make an animation out of it. And GeoServer will build through this plugin an MP4 that you can then play offline based on the sequence of images that you identified through a time range. If you want to see all of this in action, at this time I have a link. You can go to the UMEDStat viewer. The UMEDStat viewer is a public website that anyone can connect to And EUMETSAT is the European entity that manages a number of satellites. So they manage Copernicus, they manage Meteosat, and so on. And then they are publishing all of this data through GeoServer and this interface. I point your attention to the time slider at the bottom. So the time slider shows the availability of data. That orange bar means that there is data in that time range, not after it. And you can do time traveling over it. So you can choose which date you want to see. You can zoom in and see the actual time slices which are actually available. You can choose the products, view them in the map, maybe start an animation. There is also the ability to play over time, step by step. And if you like the results, then you can use the large download facilities that I was talking about through that camera over there, the camera button on the right. And it allows you to get both a high resolution snapshot of the map or download the raster data, the raw raster data, and so on. So it's putting everything that I've been talking about so far together. That's it.